This video is about grading layouts, but if you look at the techniques, you should also get some tips. Um, I am thinking though that after grading a lot of these, I think maybe Fritzing just isn't the way to go, and that maybe, in fact, there's a lot of misconceptions, and I'm going to have to create another video because there's too many common mistakes. And so, if there's too many common mistakes, um, then I think that's my fault. So, looking here, this the red is the plus, right? You can see that. The black is the minus. And you can even see where it's highlighted. Right, so all I have to do over here, because what I'm doing is reversing it, right? There's my voltage source, and then it's connected here. There's a wire that comes in and a wire that comes out. So there's a resistor, right? And then it goes into something and it comes out of something, because remembering everything on the strip line here is effectively shorted, right? So then that gives me another resistor, and the same pattern occurs over here, right? Then it comes back. We can just put the ground symbol there, but really that was what this was the series connection. Now, if you're grading this, you don't have to do it by hand just like I did over there, but you are doing it by eye. I look at it, I come in, and I just, in my imagination, I start flowing through the resistors. So this one is good. We come over here, and there's my battery. Plus and minus. So I'm just flowing here. And now everything connected on this is fine. That resistor comes out, jumps over, comes back in, and then a wire. There's a wire here. It's not really needed, but it's not shorting anything, so we can just ignore it. Comes into the black wire, and we're set. Now, unfortunately, while we can follow the current through this wire and into this path, and we can follow it through this way, through that path. So these two resistors are in parallel, right? So I can draw them like this. All right. There's no connection here. All right, we're just drawing a piece of wire over something. So it's not really proper. So this one would be wrong. Now over here, I'm not showing the battery, but I come in, I go through, and then all of these are connected on the same line. All these are connected on the same line. So I'm totally in parallel. So I would get 3 parallel resistors. So this one is correct. Maybe change color. So here we have the battery. We're going to go into 2 parallel resistors. So here's the red. All right, it goes into 1 resistor and ends up here. Then I have a wire coming through, going through a resistor, and then a wire connecting back here. So that's correct, that's correct, that's correct. Then I have a wire connecting through another resistor, and then through that resistor I go back to ground. So I have that. So that note's correct, that's correct. So this one is correct. And as time goes on, you just can really see this much more easily. Um, but because there's so many ways to draw it, no one's will be the same. But really, I just use the I'm a current flowing through this, and I just imagine that, and that's how I grade, and that's how you can check your work too. All right, what about here? So I have two batteries, and so I'm just going to draw them, and I'm going to assume that it's right. So I have plus and minus, plus and minus, and these two are connected, and then this goes through. Oops, I just now unfortunately right here it's not connected, so it's broken. Now here that resistor is in series with another resistor, in series with another resistor, which then there's a parallel path. So in fact, the rest of it's right. This needed to be connected over here. So unfortunately, that one's wrong, but it wouldn't take much to fix. All right. Now, this is on some of the more complex ones. Um, this is why I'm starting to not like fritzing, because there's so many parts um, that may or may not make sense. And even though my video on fritzing has a lot of views, it seems a lot of people hate it. And I don't know, maybe it's the video or it's fritzing. But I can't, this is a surface mount part, right? Put onto a through hole piece. Um, it's a diode, but I think maybe that's a pin and that's a pin. I don't know, let's just assume that it is. But what I can't tell is, does this go here and this goes there? All right. So anyway, so let's start here. Power supply is going in on this, which is the input. This is the ground, which then you have a wire short there, so that's right. Here's V out. Excuse me, it's V plus. This is the 5 volts right here, right? So now this whole line, right, is 5 volts. So not sure why this node is enabled plus V in minus. I'm not getting that. All right. Um, I I don't know which one this is because they're using the 1013. Because they're calling that out, but I'm pretty sure for the part that you're supposed to use, um, that's like the positive power supply. So these pins are all, I can't make it out because if this is 5 volts, usually for the 1006, this is V plus and this is V out. And for that particular one, it wasn't the LT1013. So unfortunately, I can't really figure out what's going on here, and I'd have to mark it wrong. Um, Now there's supposed to be a reference, so that comes from 5 volts, jumps up. Here's the reference line. Okay, that comes here, and this gets to ground. So the reference part is right. Um, let's see. Now the input FETs are supposed to be, the gates are in the middle. But here I can see that the middle pin comes up, comes across and gets tied to ground. You really have to use the right data sheet because the through hole pins that we're talking about, right? You have a source, gate, and a drain. I might have drawn these backwards, but the parts that you were told to use has the gate in the middle. And you might be using a surface mount FET or something. This is kind of why I'm starting to think that the Fritzing is just, it's more trouble than it's worth, because you'll pull out this part and it will tell you the pinout, but the pinouts can be wrong. We just did that. Now here we have the plus, comes in and it goes here, and the ground is here, and it comes in the middle. So really, the way this is drawn with that, the tab, right, in this order, this should be V in, V out, and ground, the way this is oriented. All right, so that's not correct. All right, here, this is the positive side of the battery. I just cut it off. This is the negative side. I can see that a wire comes around to here so that it's tied to ground. Not quite sure why it's called ref though, but then here's the positive power supply. Now then it comes here, there's a voltage division. That works, that goes into the input here. I just sorry, need to double check. Maybe I made a mistake. No, I didn't. The ones with the comparator, right, is an LT1006, has a different pinout than when we're doing this one. This just has resistors. So although, oh wait a second. Actually, this might be no. I think I can see this little knob here that means it's oriented. So I think this is really backwards. All right. But the resistor that would be biasing the diode, this resistor comes in, here's the diode, it jumps, it's not shorted, that's fine, and it comes into the drain, but then it's shorted, so I don't know what's going on here. And the middle part, the gate, doesn't seem, while this one is being driven, yeah, there's too many things wrong with it, so this one's would be wrong. Now in this case, this was the one with the the 1013, that's a dual op amp. There's two inside, okay? So you only need one package. But unfortunately, notice all these pins are on the same piece of metal. So all of these four pins are shorted together, these are shorted together, these are shorted, and these are shorted. So this is that's incorrect as well. Now here, it looks like it's a MOSFET on a through-hole thing. I guess it's in Fritzing. I can't grade it off the top of my head. But if this is out, then this line, if we're labeling this out, and it looks like that's there, there's too many things on that line. So it's most likely incorrect. Although, yeah, here's, I think the positive power supply goes to the diode, but then it's at least, maybe there's a wire connecting these down below, and I forgot to cut it, forgot to grab it. But as shown, it's open. But again, whoever really did this, they might have closed it. But same thing here. Maybe there's a wire here and I just didn't see it. All right. Now this has the opposite orientation of the other one that had this. But still, this pin here and this pin here are now shorted. Same as here, same as here, same as here. So this one's not correct either. All right. Well, you can stack the power supplies like this. The real problem with this is that you got a wire coming in and a wire coming out. You got 3 wires going into one hole, 3 wires, 2 wires. You can't fit the wires in like that, all right? And you weren't really taught that way. Question 3, and I think this one's mislabeled as well. Question 1, they should all be in series. So comes in, comes out. Okay, that one's right. It's just, notice how they're connected, but they're coming in and out of different holes. That's what you have to do. All right, here, it's all coming in here, and then it comes out, so that's not good. But the real issue is right here, where this resistor, right, is on the same thing. So that's really a resistor in parallel with a wire. It's a short. All right. Now over here, yeah, in Fritzing you can kind of say, oh, that's, I don't think you can really do that, because unless it's you really, if you meant not a connection there, then it would be okay. All right. But this looks like the wrong board, where there's just nothing but, it doesn't have like this pattern to it. They're just different holes. You could have a correct layout, but for the project that wouldn't be correct. I like this one because everything is clearly labeled, and you have the symbols, which is great, but it's also physical. Now, yeah, you can draw these like more efficiently so that you can like save space, right? Because on the board, you're really taking up 3 bays there just for having the resistor. But I just wanted to say I liked it. You come out, in through one, here, 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 and back. All right, so this one would be correct. this is a common mistake where there's a schematic, right? And this is the op amp schematic, right? Where I can draw this. And maybe it's a little sloppy, but this is a physical thing. You have to have the package, right? This is also the schematic, but the package really has in, out, and adjust is on the side. All right, that's the real package. This is just an op amp here, a symbol that you're wiring around, but these symbols aren't really physical. You really want to draw it, the real package. So this one, you just can't really grade much else because this is really wrong. And yeah, you can't have you really can't have the wires won't fit. And as soon as you go to do it, you'll realize it. This one looks right. I was just saying because the person captured so much, it's hard to read, right? I would have zoomed in and just presented just the critical information. You don't really need that half of the board. You don't need all this information. Make it easy for the grader to grade. So I have a feeling they're using the wrong part here. But that the 106, well, maybe I'm wrong. Maybe these pins are reversed. But I thought on the 106 these were backwards. But let's come over here. If this is, let's say this was correct and this was the output, it's coming in on a drain or a source, right? That on these parts, the gate is in the middle, right? And then which then, yeah, you have the positive power supply, goes to the resistor. It's not shorted because it's coming over here, then goes through the LED. And that's a great approximation. It's a lot easier than to just show a diode than the LED. Then you come here, right? But that's the wrong picture, right? It would then go to the drain, and then the drain would go to ground. But and let's see, the reference, here's the plus 5 volts. Then you have this, and that's right, right? It just goes through, this is the middle, and that's the input. Here, again, pins all shorted. This is going into the wrong one. If this was V out, it should be going to the gate. So that one's got a lot of issues. Now, if you're going to use Fritzing and you're bound to determine, I like these symbols better. And yeah, maybe I should do a better video or something, but let's check the reference. So this comes here, this is ground, this is here. And notice how they kind of cleverly bent the pen here. So that's fine. All right, so I have plus V out. Unfortunately, they've shorted their resistors on the same line, and this is ground, right? This is that node there is what you would want here. Yeah, that 1006 does have its output there. That comes in, goes around. They're going in through the gate. That's great. That must be the source. I think you're just tying that there. And then positive through the resistor, through the LED. Yep, that one's right. So the rest of it's right, but this bit is incorrect. Well, the way this is really drawn is that you've got the battery kind of shorted to ground. Or, oh wait, no, maybe not. My bad. I think what you meant is to have it here. All right. And so, in fact, though, the way this is oriented, it's backwards. So this is in backwards. Assume it's right. We'll say this should be the positive, right? I'm trying to find if this is the voltage divider, right? Here's the ground. Here's this. So that reference node is going into the wrong pin. It's probably that pin. And then what I don't see is how this gets connected. The other end of the voltage divider has to be connected to V plus, which is on this. And then we've got, you know, the diode or the LED. And I'm not quite sure actually what this is because there's no transistor. So that's not working either. This one, they're putting the plus, and they're putting the voltage supply here. So now that's everything here. That's at 9. That's the ground. Yeah, the 7, 8. Hard to tell. I can't really tell which way that's facing because see, that's the front. I think this is backwards because when you look at the back of these chips, right, what you'll see is this, and then you'll see some kind of pattern of metal, right, where the heatsink is. If you can see the numbers, that's the front. So according to the real part that we use, this is in backwards. But let's assume that we got our positive 5 volts here. We come around, we go in through the diode, right? And it's connected to the drain. The output of this goes to that. The output of this goes to that. You might think this is wrong right off the top of your head, but look, notice the symbol's upside down to the way I normally do it. So I think, yeah, I believe the op amp is right. It's just not, see that little notch? Yeah, it's just one of my idiosyncrasies where I always draw it like that. But it's valid. So just before you mark it wrong, make sure you know you got the notch in the right place. Now, this person hand drew the pattern, and actually, looks pretty good. Although they didn't label things here. But if that's the transistor, M1, I guess that's what it is. So we have out coming into a drain. So the picture's wrong, but the way that they drew it, kind of like it. It's just not right. What I liked about this is they did, even though they did it in Fritzing, then they went and rather than try to use Fritzing for everything like my video, which again, it's kind of super frustrating. Um, they just went and drew in the documentation after the fact. So I think I learned a better way to do it. Again, though, because this is the one with the transistors, um, they used the wrong part. It should have been the 1006. Um, and they've got these middle pins tied to ground, so they're using the wrong diagram. Now you might say, well, it's wrong. Why did it matter that it was documented so well? Well, it actually was really quick to figure that out, right? And it'll be quick to fix. What I liked about this is that it showed this nice compact way, and you can really put the resistors in like that. Fritzing won't let you draw it like that. I don't know. Um, I'm in a mood to ban Fritzing because it seems to have caused more trouble than it's worth. But what I liked is they were very neat. They put this circuit here, this circuit here, this circuit here. So I just liked it. Um, Here, yeah, it's the series one, and they had the positive and negative power supply properly. I just don't know what that is. Now, but it's not doing any harm, so I guess you could just leave it there. So I think, Fritzing, I don't know. It seems there's just so many ways to mess up because they give you parts that are valid but not valid for what we're using. Um, and it seems really hard to use to get nice clean layouts. If you looked at this, this is how it would really look on the board. And that's like practically a work of art. It's called artwork, right? So, still, yep, it looks like some emphasis needs to be made on the parts. People are using the surface mount part for the transistor, which has the wrong. I guess I'm just saying wrong packages. All right. So maybe, yeah, I think given that a lot of these videos are mine, I can safely say better instruction. But I know that the professors were, um, I'm pretty sure they were teaching it properly, but more than likely they were using this in class. Um, I'm going to take a vote and we'll find out. Anyway, I hope that this helps you, and happy drawing.